Hello, welcome to the video. In this lesson, we're looking at section 3.4, where we're going to be using the quadratic formula. In our Algebra 1 textbook, we talked about when we are solving for quadratics, we're trying to find the x-intercepts of those parabolas. And there are different methods that you can discover what those x-intercepts are by factoring, by using square roots, by completing the square. All of those different methods have stipulations attached to them, except for the quadratic formula. The quadratic formula works for any quadratic function in order to solve it. So as long as your quadratic is in standard form, ax squared plus bx plus c, we can use the quadratic formula, which is right here. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This should be reviewed. All right, so this should be reviewed. This is just, going through this again to kind of get us, an idea of, yeah, yes, we've seen it, but we're going to look at it much more as we move forward in the Algebra 2 textbook. So we're just trying to get more practice on it. All right, so in this particular question, they want you to use the quadratic formula. Anytime you are going to be asked to use the quadratic formula, you must set the equation equal to 0. So it's not equal to 0 in this case, so I'm going to subtract 5. So now I got x squared plus 3x minus 5 is set equal to 0. So what I like to do is, knowing that this is my general formula, I like to find a, b, and c. So a is 1, b is 3, and c is negative 5. So going into this, it's going to be x equals negative b, which is negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, and c, which is negative 5, and the whole thing's divided by 2 times 1, which is 2, because it's 2a. So I like to make sure everything gets solved inside the square root before I do anything on the outside. I guess the only thing I actually would do is I can multiply the 2 times 1, which I already did. But other than that, I exclusively solve things inside the square root before I do anything else. So I got my negative 3 plus or minus, I got the square root of 9, and it's going to be minus, well, actually, I'll do it this way. I'll put the minus with the 4. So negative 4 times 1 times negative 5, so that's 20. So it's going to be plus 20, and that's all divided by 2. 9 plus 20 is 29. And now I'm going to take the square root of 29, which gets us about 3.39. So I got negative 3 plus or minus 5.39, and it's all divided by 2. And there may be some instances where they ask you to find the exact answer. It doesn't, so I'm just going to use an approximate value. So because I have the plus or minus in between the negative 3 and the 5.39, this is essentially two different values. So this is going to be negative 3 plus 5.39 divided by 2, and negative 3 minus 5.39 divided by 2. So to finish this up, I got negative 3 plus 5.39, divide that by 2, I get 1.195. That's one answer. And then the other one, I get negative 3 minus 5.39 divided by 2. And that's going to be negative 4.195. And those are my two solutions, all right? If you were asked to find the x-intercepts, for this particular one, my x-intercepts would be 1.195 comma 0 and negative 4.195 comma 0. So here again, they want us to use the quadratic formula. I'm going to set it equal to 0. So this is subtracting x squared, or just subtracting 12x. I'm going to add 4. So now I got 25x squared minus 20x plus 4 is set equal to 0. And okay, so finding A, B, and C. A, 25, B is negative 20, and C is positive 4. So plugging it into the formula, I get x equals positive 20, because it's the opposite of B, plus or minus the square root of negative 20 squared, which would be 400, minus 4 times A, which is 25, and C, which is 4. And it's going to be all divided by 2 times 25. And you could have put that as 50, but I'll just wait. So I got 20 plus or minus, and I got the square root. So now I'm going to take this negative 4 times it by 25 times it by 4. And I get negative 400. So this is going to be 400 minus 400, and it's going to be all divided by, and I'll do 50 here. So that gets me 0. So now this is going to be 20 over 50. So 2/5 is my answer. Looking at this one here, again, subtracting 13, so I got negative x squared plus 4x minus 13 is set equal to 0. Uh, Looking at this, A is negative 1, B is positive 4, and C is negative 13. Put it into the equation, x equals negative 4 plus or minus the square root of b squared, which is 16, minus 4 times a, which is negative 1, and c, which is negative 13, and the whole thing's divided by 2 times a, which is negative 1. So going over here, x equals, I got this negative 4 plus or minus the square root of, I got 16, and then I got negative 4 times it by negative 1 times it by negative 13. That is negative 52, and that's going to be divided by negative 2. 16 minus 52 gives me a negative 36. So I got plus or minus negative 36. If I took the square root of that, that is going to be 6i divided by negative 2. The reason why it's 6i, because it's the square root of a negative number. We have now realized that we have imaginary values. It's not just no solution anymore. So because we have a value of I, we actually have, this is going to be brought up as two separate problems. So this is going to be negative 4 plus 6i divided by negative 2, and negative 4 minus 6i divided by negative 2. And looking at these two problems together, what I would do is I just kind of break this up into the two separate denominators, like negative 4 divided by negative 2 plus 6i divided by negative 2. When I simplify this out, this is going to be positive 2 minus 3i as one solution. And I go over here, this is negative 4 divided by negative 2 um, minus 6i divided by negative 2. This is going to be positive 2 plus 3i in this situation. You could leave it like this, or you can condense it and write it as 2 plus or minus 3i if you chose to. Either way, this is the same. But if you want to leave it expanded, that's fine as well. The last thing we're going to take a look at is analyzing what is called the discriminant. The discriminant is one is what's the terms that are inside the square root of the quadratic formula, so the b squared minus 4ac. And what really that determines is how many solutions or how many x-intercepts a function has. So if you have your discriminant and you find the result of it, if it's any positive number as a result, that just means that you're going to have two solutions or two x-intercepts. If the discriminant equals 0, that means you're going to have one x-intercept or one real solution. And then if you have a negative number in the discriminant, they are imaginary numbers. So like if you went back into these problems here, like this problem here, 29. 29 is a positive number. You knew we were having two solutions, and these were the two solutions that we had. Looking at this one here, oh, our discriminant was 0. We only had one solution. It just happened to be 2/5. Looking at this one, we had a negative number. We had no real solutions, so we got imaginary numbers. That's why we had imaginary solutions here. So looking at these examples here, all they want you to do is determine what the discriminant is and how many solutions it has. All right, so like say if I just looked at example B, for instance. So example B has A being 1, B being -6, and C is 9. So using the discriminant B squared minus 4AC, B is -6, -6 squared is 36, minus 4 times A, which is 1, and C, which is 9. Multiply this, I get 36 minus 36. It gets me 0. I have a result of 0 as my discriminant, so that means I have one solution. And if you need to ask about A or C, please leave a comment. I'm more than happy to look at those. But for the most part, this is also review, and you should have, in my opinion, no trouble finding these. And so with that, that is how we solve using the quadratic formula. Hope this helps. Till next time.